Chipmaking isn't about free trade anymore, but more about national security. Hello, and welcome to another episode of China Record. Chipmaking, the process of designing and manufacturing integrated circuits, is a vital industry that powers many of the modern technologies we rely on every day. From smartphones and laptops to cars and satellites, chips are the essential components that enable computing, communication, and innovation. However, chipmaking is not just about free trade anymore, but more about national security. In this video, I will explore how the global chip shortage, the US-China trade war, and the geopolitical tensions have transformed chipmaking into a strategic and competitive arena that affects the interests and security of nations. I will also discuss the implications and challenges of this shift for the chipmakers, the consumers, and the policymakers. Chip, the national security for USA. The story begins with the COVID-19 pandemic, which disrupted the global supply chains and caused an unprecedented demand for chips. As people stayed at home, they bought more electronics and appliances that required chips. At the same time, the automotive industry, which had reduced its orders for chips due to the lockdowns, suddenly faced a surge in demand as the economy reopened. The result was a mismatch between supply and demand, leading to a severe chip shortage that affected many industries and consumers. The chip shortage exposed the vulnerability of the U.S. economy and its dependence on imports of semiconductors from abroad. According to the Commerce Secretary Gina Raimondo, the chip shortage was a national security issue because it threatened the competitiveness and innovation of the U.S. industries. Chips also serve critical military applications and are necessary for cybersecurity tools. The Department of Defense and Congress identified semiconductor-powered technologies as strategic investment areas, such as AI, quantum computing, robotics, and automation. The Pentagon warned that if America did not invest in its domestic semiconductor manufacturing capacity, it would create a frightening vulnerability to foreign cutoffs whose impact would make our COVID-related shortages look minuscule. The chip shortage also highlighted the challenge posed by China, which has invested heavily in its semiconductor industry as part of its ambition to achieve technological supremacy. China has spent over $150 billion in semiconductor manufacturing subsidies and $1.4 trillion in pursuit of technology dominance. During the next decade, China is projected to add 40% of new global capacity, becoming the largest semiconductor manufacturing location in the world. China's rise in chipmaking has raised concerns about its potential to disrupt the global supply chains, steal intellectual property, or use chips as a weapon against its adversaries. The U.S. has responded to the chip shortage and the China challenge by launching a bipartisan initiative to boost its domestic semiconductor industry. The Chips for America Act, which was passed by Congress in 2020, authorized $52 billion in funding for research, development, and incentives for chip manufacturing in the U.S. The act aimed to restore America's leadership in chip design and production, secure its supply chain, and ensure its national security. President Joe Biden also issued an executive order to review the vulnerabilities in the critical sectors that depend on chips. He also met with the leaders of major chip makers and users to discuss solutions to the crisis. Semiconductor historical moment. Semiconductors were first discovered in the early 1800s. In 1782, Alessandro Volta used the term semiconducting to describe materials that have electrical conductivity between that of a conductor and an insulator. In 1833, Michael Faraday observed that the electrical resistance of silver sulfide decreased with temperature, which is a characteristic of semiconductors. In 1874, Carl Braun discovered the first semiconductor diode effect. He observed that current flows freely in only one direction at the contact between a metal point and a galena crystal. This discovery led to the development of the first semiconductor device, called a cat whisker, in 1901 by Jagadish Chandra Bose. Cat whiskers were point-contact semiconductor rectifiers used for detecting radio waves. In simpler terms, semiconductors are materials that conduct electricity, but not as well as metals. They are used in a wide variety of electronic devices, including transistors, diodes, and integrated circuits. The story culminates in the mid-20th century, when scientists and engineers at Bell Laboratories in the U.S. made two groundbreaking inventions, the transistor and the integrated circuit. The transistor was invented in 1947 by John Bardeen, Walter Brattain, and William Shockley. It was a device that used a p-n junction to amplify or switch electrical signals. The transistor was based on the point contact principle, which involved applying a voltage to a metal point in contact with a semiconductor surface. The transistor revolutionized electronics by replacing vacuum tubes, which were bulky, power-hungry, and unreliable. The transistor enabled miniaturization, efficiency, and reliability of electronic devices, such as radios, computers, and telephones. The integrated circuit was invented in 1958 by Jack Kilby and independently in 1959 by Robert Noyce. It was a device that integrated multiple transistors and other components on a single chip of semiconductor material. The integrated circuit further revolutionized electronics by reducing the size, cost, and complexity of electronic devices, such as calculators, watches, and satellites. The transistor and the integrated circuit were the key inventions that launched the semiconductor industry and the information age. They paved the way for the development of many other devices based on semiconductors, such as lasers, solar cells, LEDs, sensors, and memory chips. The story of semiconductors is not over yet. It is still going on as new materials, techniques, and applications are being discovered and developed. Semiconductors are the materials that power the modern world and shape the future of humanity. They are the materials that make possible the wonders of science, technology, and innovation. They are the materials that tell a fascinating story of discovery, invention, and progress. Semiconductor for humanity. Chip or semiconductor is important for humanity and future development for three main reasons. It drives economic growth, it fosters scientific discovery, and it enhances social welfare. First, chipmaking drives economic growth by creating new markets, products, and services. Chips are the foundation of the digital economy, which accounts for 15.5% of global GDP and is expected to grow to 24.3% by 2025. Chips enable the development of emerging technologies such as artificial intelligence, cloud computing, 5G, and the Internet of Things, which create new opportunities for businesses and consumers. According to a study by the Semiconductor Industry Association, every additional dollar invested in the U.S. semiconductor industry generates $16.50 in total output for the U.S. economy. Second, chipmaking fosters scientific discovery by advancing the frontiers of knowledge and enabling breakthroughs in various fields. Chips are the key to unlocking the secrets of nature, such as the structure of matter, the origin of the universe, and the evolution of life. Chips are used in powerful instruments such as particle accelerators, telescopes, and DNA sequencers, which allow scientists to explore new phenomena and test new hypotheses. Chips also enable the development of computational tools such as supercomputers, quantum computers, and neural networks, which allow scientists to simulate complex systems and solve challenging problems. Third, chipmaking enhances social welfare by improving the quality of life and well-being of people around the world. Chips are used in various applications that benefit society, such as healthcare, education, entertainment, and security. Chips help diagnose diseases, monitor vital signs, deliver drugs, and perform surgeries. Chips also help educate students, facilitate learning, personalize curricula, and assess outcomes. Chips also help entertain people, create immersive experiences, generate content, and connect with others. Thank you for watching my video on China Record. I hope you found it informative and enjoyable. Your support means a lot to me and encourages me to bring more new episodes. If you liked the video, please don't forget to leave a comment and share it with others. Stay tuned for more exciting content.